All right, we'll get started. So today we've got Zoe Stone talking to us about improving reintroduction to get more birds in the bush. Before we get started, I'd just like to do a quick acknowledgement of country. So the University of Queensland acknowledges the traditional owners and their custodianship of the lands on which we meet. We pay our respects to their ancestors and their descendants who continue cultural and spiritual connections to country. We recognise their valuable contributions to Australian and global society. So welcome, Zoe, and take it away. Cool.
Okay, kia ora koutou everyone. So I'm from New Zealand. Thank you for that welcome. I'm going to talk to you, as I said, about my postdoc, which I've just completed. And I've been part of this awesome research team with Doug Armstrong, Kim Parker, and Cara. And we've been part of a sort of a collaborative project about, it's been called More Birds in the Bush, which is quite apt to name because it's basically what we're doing. And our little part of it was working on how we can improve reintroductions into mainland New Zealand in terms of getting more birds in the larger landscapes of New Zealand, because in the past we haven't been very good at doing that. So first, as with any project, there's a lot of people involved, and especially when you work in translocations and reintroductions, there's generally a big group of people behind the box. And so first, just want to thank you to a few of the groups that we work with, particularly the local iwi or the Māori tribes in New Zealand. So there's Tānaki Maunga, which is the mountain in Taranaki, which has about 7 different tribes that we work with who have been working hard to protect their maunga. The Palmerston North City Council, which has funded this translocation and a lot of the predator control work at this site, and the local iwi for the site is Rangatane as well. And we've worked with Department of Conservation and Manaki Whenua as well. So just a bit of background, if you don't know much about New Zealand, we have had a very strong history in New Zealand conservation, especially on islands. We kind of developed a lot of the techniques for predator control and eradication on islands, which meant we could start putting things back. And so once we can get rid of pests, we can sort of reintroduce all our vulnerable birds, which are very threatened by invasive species. We have no native mammals, land mammals in New Zealand, except for a couple of species of bats. So the introduction of rats and cats and stoats has been a huge impact on New Zealand's fauna. So back in the 70s and 80s, we started doing this really huge sort of high stake conservation work where we had very threatened species, and we managed to get them onto these islands and secure a lot of them. But New Zealand also has a fairly big forested area on the mainland, so all this green is our current forested areas. And as you can see, the dots don't really overlap with our sort of mainland forest vegetation. So New Zealand already has about 30% of its land mass covered by protected areas or native forest vegetation. But the problem is that these forests are often quite silent. There's not a lot of birds left in them. They're very hard to control. We have a lot of rats, a lot of stoat dynamics happening, and these have a huge impact on the persistence of birds. And so what we're trying to do is kind of move away from islands and try and figure out how we can get more birds back on the mainland. And so New Zealand has a huge program called Predator Free 2050. I don't know if you've heard about it, but this is a huge national program which is aimed at removing our rodents, so rats, our three species of rats, and the mustelids, stoats and ferrets, and also possums from the mainland New Zealand by 2050. And so programs like this, which have a lot of funding and combined with a lot of community projects and council-related projects, we're starting to get a lot more reintroductions in mainland New Zealand happening because we have this habitat opening up that wasn't available before. But because of this, we kind of get this really changed dynamic landscape of predators. And so in some places we can have really good control where we have really low numbers of predators, and then we have this mosaic in the landscape with kind of fluctuating predator abundances, which means it's quite tricky for reintroductions because we can't necessarily keep the predators across a large area at the levels that we need. So these large forest areas are quite hard to manage. Trying to protect or reduce predators to the really low numbers we need across thousands of hectares in rugged New Zealand is pretty challenging. They're also very difficult to monitor, so it's pretty hard to go and walk these hills. I have sprained many an ankle wandering around these forests. And when you're trying to find small passerine birds, which is the majority of our species, it's pretty challenging. And so we have this huge problem particularly when we come to translocations on the mainland, which is about dispersal. So what a lot of people think of connectivity is good for biodiversity, you know, connecting fragments of populations is always great. We want to connect them up and let them flow and move together. But when we talk about reintroductions, it's actually a big problem. So we can put birds into an island, or we can put them into a fragment and they don't go anywhere. But when we have connected forest, then we can only manage a small area, but they can move as much as they want. So dispersal is actually a huge barrier to reintroduction success. And as a result, most of the reintroductions we've tried in the mainland have actually failed. So that's where our project has come in. And so what we've been working on with a bunch of, you know, a lot of other clever people before me, is trying to work on this sort of iterative reintroduction process where we're moving from islands, we've moved on to peninsulas where we can put a fence, and so it's sort of like a slightly leaky fence, but it's generally predator free. And then we're getting into like fully fenced sanctuaries, and they're getting slightly bigger and bigger. And now we're getting into the stage of trying to do reintroductions into mainland areas that don't have fences, and how we can get those to work. So our More Birds research project it has been collaborative with us and Manaaki Whenua, which is kind of our big CSRO type research group in New Zealand. And these are just a few of the sort of themes that we've been working on. So first we were trying to figure out what is happening in New Zealand reintroductions and what that sort of basic ecological information about dispersal, forest bird dynamics, and success rates in reintroductions. Then we were interested in improving the capacity to monitor and predict post-release dispersal. So this was really about trying to improve our monitoring techniques. Can we actually monitor birds across such large landscapes, and how do we do it? Understanding what happens when we release birds and how far they can move, and using sort of habitat selection models and SDMs to try and predict how they might move in sort of connected landscapes. And then we've also been improving the capacity to actually predict population growth and persistence. So we use a whole bunch of predictive modelling techniques to look at reintroduction success, and we kind of use this in a Bayesian framework where we can use data from multiple sites and multiple species to try and predict what might happen based on the environmental conditions at a site and that species characteristics. And then the whole point of this research has been to improve the outcomes of reintroductions, and using an adaptive management framework where we can step through, we get data, we can use that data to improve our modelling and our predictive powers, and then support improved management actions, and hopefully that will improve our reintroductions in the long term. So that's kind of like a brief rundown of what I've been doing for the last few years along with Doug and Kevin and Kara. And so here's just a little thing about that connectivity problem. So here we might have an island on the left, which, and if you know your New Zealand sites at all, this is Tiriti-Matangi, which is a very famous island where we kind of learned how to do conservation in New Zealand. It was one of the first islands which was eradicated from pests, and it had a big revegetation program. And it's isolated, it's an island. So these are just the permeability of the landscape within 2 kilometres of our sites. And you can see, depending on the species gap crossing ability, I mean, you know, an island, they might be able to go a little bit offshore, but they can't really move. And so when we have small islands like this, we're able to reintroduce a whole bunch of species. And if you go to New Zealand and go to Tiriti-Matangi, you'll probably get 100% able to see most of these birds. This one might be a bit challenging, the fern bird, but apart from that, you know, you'll see all these species. When we move on to mainland, so this is Henua Ranges, which is also in the Auckland region. It's a mainland, it's connected, it's got a core central management area, which is for kōkako, which is this bird here. So it's mainly been managed for improving a wild kōkako population there. And so they've got about 600 hectares that they manage, but because it's completely surrounded by forest that is unmanaged, there's this problem with dispersal. So things, you know, you can release something inside, but it might move outside of that. And then over generations as well, you might have juvenile dispersal, natal dispersal happening. So everything's kind of just leaving your area. And because of this, we have a bit of a problem reintroducing things. So we've tried a few different reintroductions to the site, and most of them have failed. So this is the North Line robin, which is one that I work closely with in Pupukatia, a whitehead. And these are very mobile species. We know that they're very gap limited, so they can only, Totowai, the robin can't cross a gap of more than 120 meters. So in fragmented landscapes, it's a really easy one to reintroduce, but as soon as we get into a connected forest, it can go anywhere. Same with Pupukatia. So we're really trying to bridge the gap between these two sort of outcomes with what we're doing. And one of the problems here is that we actually think that connectivity might just have a lower sort of population abundance in general. And so as we can look at sort of our carrying capacity of sites, the larger they get and the more connected they get, we might just naturally have lower abundances anyway. But then when you add in the problems of predators, these high connected sites are very hard to manage. And so our carrying capacity goes down even more. And what we're trying to get is trying to figure out what sort of threshold we can get to. We can't always, until predator free happens, which it's a little bit debatable about whether it will. Until that happens, you know, we're never going to be able to get rid of pests from these landscapes. So if we can try and figure out some sort of thresholds that we're aiming for, that will allow these vulnerable species to survive, we might get better reintroduction successes. So the first part of what we were doing was trying to improve our monitoring methods. So can we actually get the data that we need to produce useful modelling to help us with management? And so these are just some examples of some of the fieldwork that we've been doing at some of the sites. You can see it's a little bit classic New Zealand hilly and pretty forested. And we really need this monitoring to help improve our reintroductions. We use the data to inform our prior predictive models, and then we can update those models and get better, accurate information about what their persistence is like and what sort of pest control is required to keep them at in a growth stage. So monitoring is really critical for this, but it's often poorly resourced. So a lot of people see translocations as kind of like the end game. This is what we're all aiming to achieve. Once we get the birds out of the boxes, we're all good, we can leave them to it. So they don't really monitor, but then the problem with that is that you don't know why reintroduction failed. And part of the reason why it's poorly resourced is it's hard to do. And you need very good quality surveys to do it. I've done some work which is looking at if you have if you just tag on monitoring to the contract work, you don't get nearly as effective information, and that can actually be quite detrimental to your long-term management. And it's a real challenge for mobile species. A lot of our birds are highly mobile and small, so we're limited in terms of how we can actually track them. So we've been trialing things like aerial telemetry with drones and just general telemetry and the good old-fashioned wandering around and looking, and to try and figure out how we can actually monitor these species appropriately. And the quality of the monitoring is really important. So, you know, depending on the type of data that you need to do these models, you actually need to put the effort in, which is hard when we have quite limited funds in New Zealand. So one thing that we've been trying to do with monitoring is figure out post-release dispersal and establishment patterns. So this is a reintroduction site that we've done at outside Palmerston North, which is in the lower North Island of New Zealand. And this is Turitea. So it's about a 2,000 hectare area that is managed inside and is part of the main water catchment for the city. And so we released robins or tutuai into this sort of central area and tracked them for about 12 weeks with telemetry. And we were trying to figure out how far they went, basically trying to figure out, is a 2,000 hectare area large enough? So we know we had this Newer Rangers site, which was only 600 hectares, and that had failed previously. We've had other previous sites around the 1,000 hectares that have also failed. So we were wondering, is 2,000 hectares enough? Is that good enough? So we tracked them and we got some post-release dispersal data. And then we followed them into their breeding season as well and got a more idea of where they were actually establishing. And the one interesting thing about this was their dispersal was much larger. It was about 1,000 hectares, and most of the birds actually did remain in the reserve, which was much more than expected. By the end of the monitoring, we still had about 30 of the 40 released birds inside the reserve. One of them died that we didn't find, and then there was one that we never saw again. But the rest of them probably dispersed, but we can't be certain. But it's a pretty high site fidelity. And part of the reasoning for this is that, you know, it's highly connected, the site. It can go down all the way to the southern coast of North Island to the south, but on the western edges, it's quite fragmented. And also we have this sort of natural ridge line on the right here, which happens to have a wind turbine farm on the side. So it just tells you a bit about the conditions flying drones in. But yeah, so the sort of natural topography and the water catchment, we think actually helped keep them in the more secure area and meant that the more suitable habitat down the bottom is where they kind of ended up, which was quite interesting. So they ended up settling territories within only a 300 hectare area. So in terms of management, like if you're trying to protect dispersing individuals, you're going to need a much larger area compared to where their breeding habitat might be. From this information, we were able to do some species distribution modelling, which is trying to determine what sort of dispersal habitat they are associated with compared to our breeding habitat, and hopefully use the sort of information to help update management programs, particularly in these larger landscapes where we can't put resources across the entire area. So if we can get a better sense of where the dispersal and where the breeding might happen, we can target our pest control to those areas so we don't have to extend our resources further than necessary. So the next stage was kind of starting to improve our capacity to predict population growth and persistence. So predictions about persistence is quite important. We use it in our translocation proposals. So a lot of the translocations are only approved if we have high certainty of persistence, or at least probable persistence. And it's really important for ongoing management. So we can use these models to say what the current state of management is in terms of how it's impacting the population. Do we need to do anything more? We can use data to predict what will happen if we do extra management, and so we can kind of continually update these models. We can build models using multiple data, and we can use this in sort of like these unified frameworks across species and across sites. So we can use vital rates of a species, adult survival, juvenile survival, reproduction, and these are much harder data to, much more intensive data to collect. We can also do it with just adult survival and count data, and this is often a bit more what's the data that is often collected. It's a bit easier. We can also just do it with count data or occupancy data, and we can do it with a kind of a range of different data. So depending on what monitoring information you have at a site, you can actually still build these models and use it to compare across sites. A lot of sort of population modelling often uses like measures of success, so was it successful or not, and that actually reduces a lot of the predictive power if you're not using all this sort of more site-specific or population-specific demographic data. And the predictions should be able to be improved over time if we do adaptive management and we can update those models. And one thing that's really important is we've been able to, or Doug especially has been doing this for the last 40 years or so, and he's had some real good success with using single species populations and single population data, and being able to use that across multiple populations and also across multiple species. So you can start to use a single species as a proxy for another species based on their ecology and their pest management requirements. So you can use predictive models based on one species across different species as well. So this is some work that Kim Parker had been working on at Tapanui. So Tapanui is an open sanctuary in New Zealand. It's on a peninsula, so it's one of these ones with a fence along the peninsula, but pests can still get in occasionally. And so the fence was put in the early 2000s, and you can see up until sort of 2014, 15, it was fairly low pest incursions. So black is stoats and grey is cats, and they reintroduced a bunch of birds in there in 2006 and 2012. So 2006 they did Porpocatia and Totowai, so those are the kind of two small passerines that we know are slightly less vulnerable, so they're usually the first ones that are put in. And then later, because of the success of those two, they put in Tieki, or the South Island saddleback, which is much more vulnerable. And this species we had very low success rates on the mainland in terms of reintroduction. It only survives currently in completely fenced sanctuaries. So this was kind of part of that iterative reintroduction step to see if we can put it in a place that has occasional predators. The problem with Tapanui is something happened in 2017. We don't know what, but suddenly we had a lot more stoat incursions and a lot more cats. So these are just the number of counts, count the number of individuals trapped. And so we had this huge spike in incursions, but they've been monitoring these bird populations this whole time. And so we've got some quite good monitoring data to be able to predict or see the response of species and try and figure out, is there a predator threshold that we might be able to manage these species with. So Totowai and Porpocatia were not as affected by these incursions, which is kind of part of their ecology. They can handle it a little bit more. But Tiaki was where we found a bit of a problem. So in 2017, this is the abundance. You can see they were growing pretty well after their release, and then they dropped off quite dramatically. And this is in large part to the stoats. We've got a couple of models here, so recruitment, adult survival, and finite rate of increase, which is population growth. And so with population growth, we basically want to be above 1. If we're above 1, we're a growing population. If we're below, we're a declining population. And the blue line is our model using prior information, so all the data that we had beforehand, and that was not using any density dependent parameters in the model. It was just kind of random effects. And then the red line is what we modeled afterwards once we included some density dependent factors and predator thresholds into it. And basically what you can see is, we had a declining recruitment, which was had a density dependent influence in it. And this sort of, even though abundance sort of started to tail off once they started to get the incursions, we still had much lower recruitment and much lower population growth. Adult survival bounced back, but the models predicted much lower than the previous model. So we can use this information to start getting a sense of the tier population threshold or predator threshold. We know that potentially they could actually, adults could potentially, adults were pretty vulnerable to stoats. Stoats are a huge impact on them, but when the stoat numbers started to go down and the cats were going up even more, we started to get a little bit of a bounce back in recruitment and adult survival. So potentially there is a world in which we might be able to start doing these sort of tier care reintroductions to sites where we can control stoats, but potentially a few cats in the mix is not as bad as we previously have thought. And we can use this information in this sort of adaptive management framework. So I don't know how many of you are aware of this. It's a structured decision-making process that we use, and it's kind of the gold standard that we try and teach for the conservation translocation specialist group. I've just come from Perth where we were teaching this workshop over there at the conference, and it kind of goes through these steps. So when we do reintroductions, we're trying to get people to follow this sort of steps, which makes them use their monitoring and their objectives in a much more focused strategic way, so that they can actually be updated and help them with their management. So objectives are defined, and then we can develop the management alternatives from this. We can use our prior information and data to model and predict our outcomes, and then we can kind of start to make a decision. And the really important part of this is this feedback loop from monitoring and updating our management, updating our models and management. And we use a Bayesian inference in these in these modeling, so we can kind of continually update our information as we go. And so some of this work, so this is for Totawai, which is our North Island robin. Doug has been working a lot on sort of population models for these, and it's basically quite a simple population model about persistence, and basically predator density and connectivity are the key factors that influence our persistence. So we model adult females, as that is the key thing with a small population, well, any population really, but small populations, the number of females is quite important. And what we look at is we can model the adult survival, and this declines with predator abundance. We also have breeding success, which is going to impact our juvenile abundance, and this also strongly declines with predators. So Totawai are a little bit more resilient to rats when they're adults, but when they're breeding, the females do all the incubation, and they're sitting on a nest in a sort of a V in the trunk of a tree, which is pretty easy for shipwrecks to access. Our New Zealand birds aren't too clever about putting nests in places that rats can't get to. So during the breeding season, if we have high shipwreck abundances, our nests get eaten, and we also lose the females as well. So it has a really strong relationship, predator abundance on population persistence. We then get a bit of juveniles, and then we have juvenile survival and recruitment into the adult female population. And this is really influenced by, again, predator control, how many of your juveniles get out of the nest, but also connectivity. So this is where we get natal dispersal. Juveniles will disperse quite a distance away from their nest that they were born in to go find their new territory. So this is kind of the basic model that we use to look at Totawai persistence and figuring out reintroduction probabilities. So we've done this in a few sites recently. So this is Taranaki Maunga, which is on the east coast of New Zealand. It's a big mountain. It looks a little bit like Fuji. It's a nice pointy volcano, and it's a huge 17,000 hectare forest. And within that, they have this block, which is called the A24 block. So it's an 1,000 hectare block, which every 100 meters there is an A24 trap, which is one of these self-resetting traps. And this is one that's working nice and effectively. And though I didn't line the rats up, that's what they look like. So yeah, each of these little dots is one of these rats, and they are able to control the rat abundance in this block quite effectively. Generally the rat tracking rate is about 8%. So the rat tracking rate is when we have rat tracking tunnels, if we have 100 tunnels out and 8 of them have sign of rats, that would be an 8% tracking rate. So we can get a sense of the relative abundance of rats in the system. Generally for reintroduction, we try to aim for at least a 20% rat tracking rate. 5% is kind of the gold standard. If we can get below 5% rat tracking rate, we can have a fairly good sense that birds will survive in that population. So with this predator control, they've been able to manage the site quite well. But the problem with this site is it has really high connectivity. As you can see, this green is all the forest, and we also have a whole lot of riparian planting along all the rivers that come out of the forest. And so there's a huge potential for dispersal. And in 2017, because of all this work that they've been doing in the block, and they were managing to control rats, they released Totawai to the site, and we've been doing the monitoring for that bird alongside the local Māori group to kind of keep an eye on the birds. And so all these blue dots are where birds have been sighted, and the first few years it was going really well. So we released them just in the middle here, and we're able to see some good population growth. And at the height of this population, they were getting up to sort of 20 or 30 breeding pairs, which is really, really great. So we were able to use prior data from a whole bunch of different sites that Totawai have been reintroduced to previously, and look at the potential growth expected on those sites. So the red is our projections based on the prior models, and so you can see that there was expected to go, but there was a bit of uncertainty about how big the population increase would be. Based on the actual data from Taranaki, so this is the posterior model based on the actual data from monitoring, and you can see that the population did grow, and it was well within our predicted estimates of population abundance, which was great. And so what we were able to do with this data is update those models. So this was the original model. What we can do with all the monitoring data since 2017 using count data of banded and unbanded birds within the block, we can update our models. So the red is our prior model. So based on female annual survival, we expected quite a high annual survival, and the blue is just the data from Taranaki. So if we just use the site data, and then if we put it all together using all the previous data and the new data to update that predictive model, we get the posterior model in purple. And so we get very similar adult female survival, but a much higher estimate. So our uncertainty in that range has gone down. We can also look at recruitment rate, which was a similar thing. Prior models expected it to be kind of a bit lower, and the real data was much higher than expected. And finite rate of increase. So again, 1 and above is population growth. We expected it to grow, and it did kind of meet our expectations there. So that was a really good outcome for that. Recruitment rate is kind of based on our fledglings per female and juvenile survival. So kind of similar things, showing that our prior models fitted our posterior models pretty well, but we just can reduce our uncertainty now that we can include site-specific data into it. So this has been a really good tool, and we've been using this to help them inform their management at the site. So what we can do is now start to predict what happens with rat tracking rates at the site. So if we just look at the Taranaki Maunga site, and we've got our tracking rate down here and what we expect our population growth rates to be under the current managed area in blue and what they were originally managing. So if we didn't mention. So this block was originally this size. You can see they changed the direction of the traps. But when we first did, or Doug first did the population modelling for this area and suggested it wasn't big enough in the original area, so they expanded it. So this is what these two lines are showing, the original area and the larger area. So based on the size of the site that you're managing, we can get some really good models of predicting what our rate of increase might be given a certain level of predator control. And it was looking pretty good. So, you know, we were expecting fairly good population growth at the site, up to sort of 60% rat tracking rates. And then we can then use that data to kind of predict future sites. So if we were to do it in a future site, what sort of our rat tracking, how would our rate of increase be depending on the size of the site and the rat tracking rate? So you can see here that generally, if we get really small sites in connected forests, we can't actually keep the predator control good enough. There's just too much edge effects and too much reinvasion. But as we get bigger sites and you're getting good control, you can start to get that population growth. So we're using this to help us with future site selection for reintroductions of totoi and other species. The problem with Taranaki, so they were going really well. So during the first few years of the reintroduction, their rat tracking rates were kind of hovering around 10%, which was really good. And as you can see, kind of that was expected to have pretty high rates of increase. The problem in the last couple of years, we've had a few issues with getting the traps reset. COVID got in the way. There's a few delays with getting all the gas canisters that do the self-resetting. And so in the last couple of years, they haven't redone their rat tracking rates last year, but they have done some outside of the block, which are sitting around this height. So if that is the case, that's happening in the block because of the delays in predator control, we're starting to get an issue. And I have been monitoring this population, and this is what we're getting. They got up to about 30 pairs in 2020. The last couple of years, they've declined a bit, and the current estimate for this year's monitoring, which I finished about a month ago, was about 8 pairs. So they kind of have had quite a big spike, and they're also at the end of a 1080 cycle. So they usually try and drop 1080, which is a poison, to kill predators. They usually do that in a 3 or 4 year cycle, and they've been delayed a couple of years in their 1080. So that, in combination with having an issue with their trap resetting, seems to have basically made the rats spike. We're getting those rat tracking numbers done now. But yeah, at the moment this is being used to help them inform what they actually need to do next to try and get that population growth back. So back to Turitea. So Turitea, where we were doing the dispersal monitoring, we also wanted to do this population modelling to see how effective their predator control was for long-term persistence. So this was the level of predator control that they currently have when we did the reintroduction. Each dot is a DOC 200 trap, so that's just a kill trap but not resetting. So you have to go out every month and reset them, and then every triangle is a bait station. So it's a pretty extensive network, but it's not as tight as we would like for really high effective rat control in mainland New Zealand. It needs to be kind of a bit more abundant, but we thought that they would possibly survive at this site. The rat tracking rates were generally around the 20%, which is that sort of cutoff that we thought some sites have been successful before at that level. So it's got about 3,000 bait stations and 1,000 traps in it, but it's got that sort of moderate connectivity. It's not nearly as connected as the Taranaki site, and it's double the size. So they reintroduced totoi in 2021. We reintroduced 40 birds, and this is our prior modelling of what we predicted the number of females to do at that site. So we released 40, but we expected about less than 10 to actually remain. With these sites, we usually expect a sort of 60% mortality of birds after we release them, whether that's from dispersal or deaths, we haven't determined yet. But we expected the population to grow, but there was huge uncertainty in that. It was either going to go to 0 or take off and be fantastic, which is why we did this very intensive monitoring program at the site. What we actually did have after release is we had a pretty good establishment rate, so we were higher than expected. We had about 11 or 12 females established pairs at the site. So in terms of our uncertainty regarding dispersal, it was much less than we expected. The problem with this site came in the first couple of years. So we had Cara, who was our master's student, and she spent a lot of time wandering around the site looking at breeding success in the first year after we released them. And we had a little bit of a sad story. So we had a lot of this happen. So this is a nest with a few gnawed on chicks. And based on that, we had some new data collected. So the blue is our data and the purple is our updated models. And so you can see our adult annual survival was lower than expected. So at the single year of data at Turitea was actually terrible. We lost quite a few females, and so that brought our adult female survival rate down. But when we merged them together, it wasn't quite as bad, but it was still not good. Fledglings per female, again, we expected it to be a bit higher. The real data and the posterior models told us another story. We didn't have juvenile survival data yet for the updated models, but then our final rate of increase was lower than expected. So we did expect this population to grow based on prior data. When we got updated information, that kind of changed our scenario, and we've hovered below the one for lambda. So it wasn't looking good for this population, but because we had a really intensive monitoring program, we got this information really quickly. So we released birds in April, and this data was collected from October till March. So basically within a year, we knew that this site was not looking good, and we needed to do something about it. So what we did is we came up with a new model. So basically predicting what our rate of increase was under the status quo, so around that 20% rat tracking rate, which is the solid line, whereas the dotted line here is that actually what happens if we could get our predator control better. So if we could bring the predator control down to 5%, we might be able to shift our population growth above the one line, and we might be able to save this reintroduction. So luckily we've had a really successful partnership with the council and the iwi, the Māori tribe here, and they had a very strong perception that they couldn't let this reintroduction fail. In New Zealand, there's a big relationship that is created when we release birds. The iwi and the managers from a site where we source the individuals basically are gifting you these species, and it creates this long-term connection between sites. And so they saw it as a responsibility to hopefully not to let these birds die, and keep up their end of the bargain and look after them. So we were able to use this dispersal modelling that we did for habitat suitability, and implement some changes to management. So here we have the dispersal range that I modelled based on what we knew about post-release dispersal. And within that range, we added in some of these 80-20 traps, which are self-resetting. So they're kind of a beefier version of the 80-24s used in Taranaki. And so each of those black crosses is an additional trap on top of that existing trap network that they had. And we got that to match the dispersal to hopefully help with the juvenile dispersal rates. But we knew the breeding success was our problem. So within that core breeding habitat that we predicted, we went out and hammered the rats. So every single dot of these is a striker bait, which is a little plastic biodegradable tub that has poison in it. So you can basically go very fast, very easily, and staple these to a tree as you go. And so our predator control team went out and deployed about 20,000 of those in that 300 hectare area to see if we could make a difference. And luckily it did. So here is our updated models base, which has incorporated the second breeding season data. And we had a much higher success rate in our breeding. So here's one of our birds sitting on a nest that is still going and hasn't been eaten. We managed to get those rat tracking rates basically down to 0. We didn't have many tunnels in the area, so we put some more in, but based on the few that they had, it got down to 0. So we basically wiped out the rats in that core area. And so the purple is our updated predictions with the second year of data. And as you can see, we've been able to shift that across from our first years of data from the blue line. So still not what we expected from the prior models, but we're getting close for our rate of increase. We're getting close to that 1 mark. And so this was a really good sign. We're able to use that monitoring and modelling data to kind of enforce their support their management decisions. And going forward, they are continuing with this rat control. So hopefully with another couple of years of data, we can start to shift that predictive modeling a little bit more. Yeah, so that's kind of wrapping up what I've been up to the last couple of years. I just wanted to just finish with this was a really cool reintroduction we did earlier this year to Bushy Park, which is a smaller site, but it's a really amazing forest which has had a few things reintroduced. And this was kind of the first reintroduction both me and Kevin have done, which was iwi to iwi led. So it was a Māori tribe to another tribe, and it was really important because previously in science and reintroduction it's been a little bit white. You know, some managers come in and it's like, I want birds, let's do it. Like, okay, put it in, and we might get support from iwi, but this one was really driven from the iwi themselves. And it kind of reinforced this idea of reconnecting partnerships. So for them, it wasn't just about getting the birds back, it was about creating this new and long-term partnership between the different sites. And so, you know, doing all this work to be able to monitor and improve decisions helps them or supports them in maintaining this long-term relationship. So yeah, kind of want to remind you what it's all about is it's not always just about the birds, it can have some other long-term lasting effects as well. So yes, thank you.
Are there any questions for Zoe? Yeah, Rich.
Thanks very much, Zoe. Brilliant work. Can you mentioned like 120 meters is sort of, I don't know, some kind of connectivity threshold for some of these birds. Could you not just cut like a fire break around some of these large controlled areas? And obviously that, I know that's destroying a bunch of native vegetation, but the payoff could be huge if you could limit dispersal without building an expensive fence.
Yeah, so that is a potential. A new site that we're working on actually is kind of doing that. So using these sort of dispersal models we've created, that we have a new site up in the north and Northland in New Zealand, which has a lot of exotic plantations around it. And so we've kind of been able to predict where the movement would be through these exotics. And the managers are like, well, let's just chop them down. So we've been able to like completely reduce potential dispersal at that site by removing the areas. Yeah, I mean, in terms of larger areas, I think, yeah, we don't like chopping down things. So in terms of chopping down native forest, it might be a bit controversial, but I guess the problem is it might stop the dispersal, but it doesn't stop the rat and
that's right. Yeah, so, but at least it deals with one half.
Yeah, so it could be. And generally when we put in fences, they do have that gap as well, but I mean not that big.
Okay.
Yeah, but it could, potentially. I mean, Totoai are one of the more restricted ones, so some of the other birds can. I mean, we have a lot of limited species. Generally, 500 meters. Like I don't know, 80. I think it's like 80% of our birds can't do more than 500 meters type thing. So you can have quite small gaps, but we are a much smaller country than Australia, so even 500 meters is still a decent chunk to cut out. Yeah. Yes.
Thanks, Zoe. Great talk. It's a really nice illustration of how to do adaptive management properly. So yeah, it's really impressive. I was interested in the hypothesized relationship between density and connectivity. Is that? I'm just wondering why that happens. Is it simply just individuals moving out into poorer quality habitat if it's connected, or is it just predators getting in?
Yeah, I think it's. Yeah, so it's probably, so that is a hypothetical kind of thing that we're trying to test right now. But yeah, I guess when you have a larger landscape and you have your food resources more spread out, we just expect this population to be more spread out, so the carrying capacity might be lower. New Zealand has quite a dynamic food resources that move around. So we think that also when it's connected, the food resources are more temporarily spread. So again, species are moving around the landscape a bit more as they're moving after our Massey species and fruiting resources and things. But yeah, it could also just be as well that a function of the predator densities as well in those large connected landscapes. There's more predators, so that keeps them down at lower levels.
Yeah, and I guess when you're probably introducing species into a site, presumably the density around for that species is low.
Yeah, so you get a lot of yes. Yeah, I mean, a lot of the, like with the Taranaki, you can kind of see they do actually settle close to each other. So there is a bit of a density dependent thing happening when we release them. So they were released here and they basically all just went down the stream. There's a main stream here. And so most of our populations, most of our territories, new territories form like 100 meters down from the previous one. And they so they do kind of, a lot of species do like being close to each other. So yeah, when you have a lot of space and also reintroductions, you know, they go through the stress period that they don't know where they are. So there's that higher dispersal than would normally be happening with their natural sort of just spreading out. Yeah.
Yeah, I was wondering if you had enough data across all your sites and had like covariates that could maybe affect those parameters you fit at all those areas you fit those models. I'm wondering if you could produce, using all the stuff you've done, a like New Zealand wide or something like that, prioritization for translocation using
that's what I want to do. I've been talking to Jeff about that. Like, how do we do this? Yeah, I think we do for some species we might be able to. So Totawai, because it's less vulnerable, we have a lot more data on it. So we have a lot more of that information about thresholds and potential breeding success. We've got about, I think there's 16 sites that we have this sort of data for, whereas most of the other sites we have like 1 or 2 species. We have 1 or 2 sites with monitoring data. So yeah, with Totawai, I think we could definitely probably do something. Well, I'm not a prioritization type person. I get Jeff to tell me all that stuff and tell me I can't do it based on the
not
data
even
I
a
have.
prioritization, just like a map. You produce basically a map of land that's effectively, and you would you would just take that and say this is where they likely succeed.
Yeah, that's what I would love to do next. That's a big funding grant to do. Yeah.
So you, in that last example, you showed that you were worried about the declines in population after the first year.
Yeah.
And then they kind of stepped up the trapping management and managed to reduce that rate, and you saw an increase.
Mm-hmm.
From that data, do you make kind of predictions about what is the rate of management that you need to implement in order to have some sort of like compromise? Because maybe it's not sustainable to put that much management effort in every year. So is there like an optimum where you can say you need to do this level of management and that will be enough?
Yeah,
I guess that's what you're working towards.
Yeah, that would be the ideal thing to be able to give managers, like this is the rate that you need to take for it. Yeah, so we did suggest, because they just, when they went out and did all that tracking, like this was just absolutely nailed. And we're like, well, maybe you don't need to put 50,000 out. So I think this year they only put 10,000. So they did, because this time, the first year they did 2 bouts of 10,000 stations, whereas this year they're just doing 1 bout, and we're seeing what that will do in terms of so part of that, we put a lot more tracking tunnels in this area to get a much better sense of what the rats are doing. And so if we can get a sense of what that level is that they need to actually achieve, that's what we're trying to do.
Yeah, is this like sustainable long term in terms of costs and things like that?
Yeah, so I mean this sort of targeted approach, so we kind of we did the sort of consequence table with the managers to try and figure out, do they just want to do like it across the entire reserve, and we costed that out versus just this sort of targeted area, and it was much cheaper, and luckily the council there was willing to spend the money and they were totally on board with it. But I mean, the idea is for other sites might not be able to do that as often, and also this is a lot of poison to put into a water catchment. So these are the water catchments for the town. If they knew what we were doing, people might not be very happy with us. But so trying to optimize how you're putting out baits is the long-term goal. So hopefully we'll see what happens this year. And depending on what the rat tracking rate is, and again the breeding success, which is breeding season is happening now. If we get a similar number, we're going to also probably do a reinforcement, because there's just low numbers in the population now. So that will also help improve what their management requirements are. But this particular site, they were very determined just to do whatever possible. Whereas the site like Taranaki, it's a much larger area because they're managing that entire mountain, and they have different predator control areas, and that block is just one of them. that takes a lot of resources for them, so they're very much interested in trying to find what that optimal level of control that they need to do is. Yeah.
Any questions in the chat?
No compliments. Sorry, I put a lot of model graph
But
pictures
John,
up.
I've got a follow-up. I feel really embarrassed asking this question because I know nothing about statistics at all, especially Bayesian.
You're gonna test me, I'm not very good at that. I just do what I'm told.
I guess I was wondering, and I'm probably totally wrong, but Bayesian, doesn't Bayesian updating kind of work towards trying to estimate a parameter, right? But isn't the issue here, you're changing the parameter as you go along,
Yes.
particularly when you've done the, the interventions and you change the parameter. Is it then, if you then update, this is where I'm probably wrong, my interpretation is probably wrong, but if you look at the prior probabilities, is it still estimating the same thing, or is it right to kind of smudge the two models, I suppose is what I'm trying to say.
So the posterior basically becomes the new prior.
Okay.
Yeah, it makes sense. So like if we were to use all this information for a new reintroduction to predict the probability, that posterior is basically the new prior because you're adding all the information back together to create a new one. So for the specific cycle species that we're working on, we can get a posterior, but then hopefully as we do that iterative reintroductions, we will use that posterior as our new priors with the new collected data together.
Okay.
Yeah.
So is the posterior only based on the kind of updated,
Yeah.
like
So
post-intervention?
Yeah, or the updated post-intervention or whatever the new monitoring data is. Whatever new data that you can get from that site or that species, you can add that in to create a posterior model compared to your prior model. But if you take all that away, the posterior model just becomes your overall prior model. If that makes sense. Stats people might be able to tell me I'm wrong, but
But presumably you would get I think your question was about if you implement a management action, is the prior without the management action valid?
yeah. Well, so basically, yeah.
Whenever
So
you take your prior.
yeah.
What
So
did they
as you
get you to say?
get more data and more reliable data, that prior becomes more irrelevant. And you're getting more, as you get more site-specific information that can update into a more complete posterior model, your prior model is less important. But you can, you still use it as the background of what you might have predicted based on without extra information. Yeah, Doug's more of a Bayesian person, so I'm probably not doing as good of a job as that.
Cool. If there's no more questions, thank you so much